All right. Um, where I left off yesterday, I had set up the new concept of the reaction and kind of got it working. Death checks were built into the main loop. And that's still true. There's this like loop state thing, and this represents the main core loop. All the whole state machine stack runs as a data structure through a main loop that looks like this. And they have some interconnections between them. Death checks can skip to post amble, for instance, and it can skip to, and it can do a stack pop, which then goes to the init of a different node on the stack. And so this is all up and running, and I was done at the end of the day yesterday, but found a little extra energy last night before I wanted to be done. Didn't fully build the new system, but I did sketch out what the new death checks would look like. So let me show you that real first. So I was yesterday sitting here commenting on how everything in here looked so much like the rules, one of the rules in the system. Like it looked like one of the game rules that could just run on the rest of the main loop. So the death check would be the pre, right? We have an any dying, which is now a part of the subcontext. Let me see here. The idea is something like you run the death checks, subcontext any dying tells us if we saw someone dying at the beginning of the death check. We run certain events. Then we state which kinds of moves we want. Over here we have run the death checks, and then if anyone is dying, we go to the player decisions, which is again just saying go to get the moves for one way or the other. This is saying get the player to choose moves next, right? This choosing moves by the player happens after the pre of the rule in the rule system, and here it just flows from there to there, which does the same sort of thing that the player decision is going to do. It does the setting up the moves. This happens in player decisions up here, right? We get the all moves, and then we run bot brains. That's up there too. And finally, you run the moves, which is this part, which parallels the run the moves from the main loop. Shuffle and run those moves that were gathered up from the bot brains. Then there's a discard step, which is the post of the new death rule that I wrote over here. Here it's saying discard any of the dead characters, so any characters that are marked for death. Here it's the same thing, except we want to remember if we initially had any characters that were dying to begin with. But any characters who were marked for death and still have 0 hearts, they get discarded. And then we recur. So in this case, we go back and do more death checks. Now here there's an else that doesn't exist before, because this is how we get to the exit state. And the exit state before was being transitioned to straight out of the preamble, but that's not really how things work. If you run the preamble, then you just have to go through the no-op of the middle part and then run the post-amble to get to the end. So there's a little difference there. I could say that I want to make an expansion to the rules that say a preamble can just do a go-to, and then that skips over any moves, and you just go into a new state right away. That could be a thing I want. All right. And then I wouldn't have to do this part. So that's how it looks. I have not actually plopped it in and got it running yet. It's not real. It's just a sketch. And as I was sketching it, there is one big thing that I was noticing might become the real point on which this turns. There are two things, but there's one that I had not appreciated yet. So during some of these other preambles, you can see what I do is I set up things like, what fixed moves I want to do, or if it's like the fight preamble, I assign one quick action and one action. That's the number of moves everybody gets. Here, everyone gets one reaction. So these are, both speaking the same language with regards to how preambles work and how they set up moves, which means, that's good. That means it can work off this language. And that means I have to go and make sure I've written the emergency first aid rule in a way that complies with that. And so I think that part is done. So emergency first aid gets used. Yeah, so it's classed as a reaction type of move. And then we just say that it can get used here. Here's the thing that we're missing. We're missing a strong vocabulary for set sort of constructing sets of these tiles or these moves. When it comes time to generate a set of moves, I still have a bit of haphazardness happening. The condition is a step in the right direction, because I just need a sort of built-in extra way to condition these things so that I can sort of overscope them and shrink it down by some extra logic. But the thing is that the overscope, this large scoping is just way too big right now. So like right now, for instance, for this to make sense, emergency first aid makes sense if we are also in the dying machine, right? The death check. This should say death check here. Death check machine. Right. So there's something missing in this vocabulary for how I could fully express the sets, and I think when I run into that, I start getting flustered and sort of spam out new ideas that don't quite gel, because they're each trying to solve this problem, but just in a local way. And what I need is a solution that's in the core, that's part of the system, that's part of the vocabulary of the simulator, that organizes the solution more carefully. And the solution that I'm getting at here is basically when I say, hey, we're going to generate some decisions here, the way I do this is I attach to each party, and I could change this. I think we're basically at the point where, at least so far, I would only need one of these, because the decision is always broadcasted to all the parties that are quote unquote in play. That's usually one or two right now. I guess I have some visions of simulations that wouldn't be just two, and it might get to the point where there are supposed to be asymmetric rules about what kinds of moves are being made simultaneously. I really don't know how I would want to go about structuring that, though, and I don't. So the point is, right now I assign these on the level of parties. Really, it's always to all parties. So it's a little bit more like the vocabulary is just, here we are picking the set of what kinds of moves are possible right now. Right? There's some kind of set selection criteria that I want to specify here. And right now, that's not even what's happening. When you do this, then what happens is it goes into player decisions and it gathers all of the moves from tiles. What that means is it runs a gather moves event, and any tile that has hooked that can generate some moves, and on top of that, any tile that says it can be used, so anything that has a this used, is immediately a usable move as well, right? So the gather moves is a little different. A gather moves hook says run this extra code when you're gathering moves, and what the extra code does is make more moves possible. So a tile can say something like, while this, the sleep tile does this, while this character is asleep, when you're gathering moves for any of the allied characters, give them the move Wake Up, which they can use to wake up the sleeping character, right? So some tiles use the hook to put moves into the set of possible moves, and the moves are different from the tile generating them. And others are tiles that set on the character, and they simply stand for the fact that they are a move, right? The character, that tile is a move, and so because it's on the character, it is available. And that's it. That's the entirety of how things get added. And what gets added is always the same right now. When I do moves gather from tiles, I mean, depending on what characters and what tiles they have, it's not always the same. But given a fixed set, the hierarchy of entities with characters and tiles, if you don't modify that, then you get the same thing every time. So the point is, it's not conditioned on parameters, right? There aren't outside parameters. I just say whatever the current state of active parties is, use that to generate my set of possible moves, and that is not conditioned by things like what the tile counters are, or the move counters, or other things. What I think I need to do is to sketch out just a list of cases of things that work this way and work out the vocabulary I actually want, because there are things here like this is saying that the number of moves everybody gets is one reaction, and that's not being accounted for in like a way that's not being used to pare down the set, which it could be. But another thing I could be doing is just saying, well, I did start this off with the idea of these being flags. What if, and at the time I was using the flags as flags, maybe there's still an argument that that's what I want. Maybe I want something like this is a reaction, and more specifically, it's like death or dying or something, right? It's a death reaction or something like that. You know what I mean? I mean, I could just make a new move kind for every single special case that I have as well. But the problem is these counters, these counters are tied in with these categories right now. And maybe I want two separate things. Maybe I want a set selection criteria of categories, and then that would be things like death reactions being a category. And actions being a category, and quick actions being a category. And then I want a like move kind, like a main move kind that tells us what counters we're dealing with. You know what I mean? They're sort of like two separate systems, and the fact that something can be a reaction and more doesn't mean that reaction isn't special, right? Like the reaction could still be also this move counter thing. Part of it, though, some other things happening here are like, do I actually like the move counter system the way it works currently? I don't like the fact that it runs on the tiles. Feels arbitrary and sloppy. But I mean, it is the point of the tiles to be able to do that. So I don't know. Maybe that's still fine. The thing that sucks about it though is that there's so much work to convert from move kinds to tiles and move kind flags to tiles. To the point that I kind of wonder about, like, if I'm gonna specify a move kind list, if I'm gonna make these sort of tags, maybe they're more like, I should call them tags. But I want to do the sketch to get to this part. So that's one thing I need to work on. But the way it's set up right here, I believe emergency first aid should work, because this becomes usable. This becomes usable whenever you're assigned a reaction. Right now, that's only at this time, so it works, but really that means that reaction is being used to scope us to the death check. And I don't think that's the part that isn't finished. I want to be able to say we're scoping to the death check in a more explicit way here, and then think about whether the word reaction is what I want. The upside to having this reaction piece, just thinking this all through out loud, is things like quick actions don't always have a strong filter. Like actions and quick actions are kind of built to be things that you can do just about anywhere. And that's not true of all of them. Some of them do have a condition as well, but they um but in general they could show up in something like a death reaction, right? If I just said actually this is a quick action and the point is that it's going to have a secondary category that we're going to flag on it, so it's really a quick action. Reactions are just a temporary kludge. Really, it's a quick action. The problem with that is the way set building constructions work. I might have to put in extra work to make sure I'm not getting stuff that doesn't belong during a death check. And one of the ways to do that would be to have a special category of move called a reaction that is only ever used for narrowly scoped special events. Okay. Anyways, that's one of the things I want to work on today. The other thing would be, first, I think if I plugged this in place of the death checks, there's another thing, and I was talking about this yesterday. The other problem here is right now death checks are default behavior. You run the move queue, and then you go to death checks. That's different from how states that I've thought about previously work, right? When you are in these state machines, you're in a specific state, you're executing the rule for that state. And whether it's in the preamble, which is currently disallowed, or in the postamble, which is currently the only way it works, its job is to transition to another state. And if it wants to, it can do that by saying transition to push a new machine onto the stack and set up a return handler for when that machine gets popped, right? So you can say just go to another state, or you can say push another machine on top of the stack, and now that one's going to run. And when that one pops, this thing registered some code that explains what to do next at this level when you return from that. Now, I don't love that system to begin with, but because that's how this works, the question is, when can you do the call? Right now, you could imagine doing it in preamble without an issue, but it's not set up to allow it. It's only possible in the postamble. And so what would have to happen is that every postamble would then include first a call to death checks. And then it would have to do this return handler thing. And so the fact that it's so cumbersome to make these calls is a part of the issue, actually. Yeah. So I guess what I'm now contemplating is, what do I want to do about that? The biggest issue here is the rule makes perfect sense, except that I have to figure out how to know when to call it. And the idea is it could be a default rule, which would mean that after any time we run the move queue state here, we actually run an entire stack push to do this thing. We could also like scan for deaths first and say only do this if there actually are any deaths, right? I mean, there's an option to do it that way. Just to optimize it, but it would still be hard coded here into the main loop that death checks happen anytime you do shuffle and run moves. And And that's appealing because it's so simple. It gets us off the ground here. Another piece of the puzzle is, when do I want the KO checks to happen? So right now, KO checks are the separate thing that happens. Death checks figures out which characters need to get discarded. Then this figures out which parties are completely knocked out. So if a party has 0 characters who are still alive, then that party is dead, and then this does not return good, and we don't do a post amble. This might actually all be wrong too. Like, this might not be totally right. I mean, this is correct for now, and the reason it's correct for now is because all the post ambles we had, the first thing they did was always the KO check. And I think maybe it makes sense to wonder if the KO check is more like a part of the death check, right? Because I could imagine a thing that's like, okay, here we go. When we run the preamble, after we're done, we have this spot where we're going to the exit states. What if we just ran a KO check too? We said, hey, some of the we just did character discarding, so some of the parties might be knocked out. This is when you need to find out about that and set their states. The only issue is, once you set their states to dead here, they're dead in the death checks machine, and you go you go back down the stack to whatever rule was running and go to its post amble, and the states it will have won't actually be the same because of the way machine frames work. Right. The fact that this call is default now means that the post amble isn't written in such a way that it's automatically expecting to deal with a return value from death checks. But that's what we would actually want it to do. We would want to say, hey, whenever you finish a post amble, since death checks are default here, expect that call has happened. And then if you're going to make more calls, then you're setting up more things, right? This is a shift in how I think about what's built in and what's happening in the in those post amble, those rule post amble. So I'm not really sure how to get a handle on what I want here. It's a little daunting. I might just need to write it a couple different ways and see how things start shaking out. I think what feels right is the idea that KO checks would be built in here means that figuring out, like, it's at the right spot. You don't run KO checks whenever. You run whenever death checks have occurred. Of course, the funny thing here is we're running the KO check when we don't have any dying. Again, if we were to check if there were any dying characters before pushing this, that would be good. Maybe this is, like I said, this sort of an idea of an interrupt. So shuffle and run moves runs, and when the moves are done, right, we do run moves, and that can sit there running all those moves. And when it's done, then it doesn't go to death checks, it goes to interrupts. And interrupts are things like a chain of currently active interrupts, like death check, which comes in and goes, okay, before I push a machine, I can run a little code. It says, if the if there are any characters with 0 hearts, then call the death check machine, right? And when we finish that machine, we come back and we run more of these interrupts if the interrupt rule fires or something like that, right? So then what would happen is, the reason that's cool is that then encounters can be these things too, right? That's kind of what an encounter is. If we look at the journey is the spot where we call the encounter machine. So we're on a journey. We make a decision about what to do with the chunk of time for the day. We usually travel forward, sometimes stop to camp, whatever. Then, if you're traveling forward, then there's a random encounter spawned for you, and you like flow into that machine. And that's written as a post amble that is doing this funny heavy duty call thing that has to happen, where it sets up a return handler, and when the call returns, then the current return handler continues from there and processes the return state from that encounter, right? It checks what happened. What would now probably happen is I would say, no, what's going to happen is this is an interrupt. This is the postamble. This is what should be happening when everybody's done. Um, like, this is what you meant to do, is check if the people are dead or if they fled or whatever, advance time. Like, this is the postamble to traveling forward on your journey. This is actually an interrupt that you wanted to schedule from, like, right here. It's like schedule an interrupt, random encounter. So I could see it making perfect sense. And instead of having return handlers, what would happen is when you return, you're always returning from an interrupt, and therefore you are going into a postamble of a rule. The only issue is, how do multiple interrupts compose together into one action? Right, that is the last of the thorny subjects. If I'm going to schedule them ahead of time here and have rules like, okay, when I schedule one, this is not a permanently scheduled encounter, this is just scheduled for this particular instance, right? So I could run the encounter table, roll, like, do it a draw from the encounter deck here, and then schedule the interrupt for that encounter, and then down here, and then that would all happen right here, and then this is just saying, okay, so we expect to see some kind of state saying whether, yeah, we're expecting some end states here. These end states could be just exit or dead, or they could be encounter fled, because we ran an encounter, and sometimes you flee from an encounter. So if that was the state we got to, then we want to know about that. But these are looking at the returned states, so the states from the previous level up. And if the first one was going to be death checks, right? First we were going to do a death checks. What we could say is that there's some kind of compositional rule. If death checks mark anybody as dead, then the other interrupts all have all been canceled or something. I don't know, actually. This is where it gets tricky. Who's going to handle the result from, if I say I travel, why would there be a death check? Let's say that you have poison, and the rule of poison is that every time you travel, or for every hour that passes in the there are 8 hours in the cycle of my time cycle, the time chunking mechanism for the making the rhythm of the game. So for each one of those hours that passes, you take 1 damage. If that's the rule, then then a death check can occur. Make some other stuff complicated too, like when the time events happen. I'll get there. So, if the time events happen in a postamble, which is currently how it works, technically they don't even happen there. They happen. The time events are happening in the main loop too. So there might be some way to frame time as a rule. I'm not sure. Let me think. Let me think. The idea that a death check could happen before the encounter isn't an issue, but the death check would then be returning. So one of the weird things about death checks, I didn't like stop and talk about this, but you'll notice that the actual clauses, like the rule pre and post, are these little things that call to the functions pre and post. Because of my whole multiple state, multiple parties with states thing, that whole thing, um, in order to work for both one and two party death checks, I have to like specify all these manually. I think it's stupid. I'm gonna get off of this sooner or later. The state arrays might be on the chopping block today, honestly, but it does highlight the weirdness that this is the first time I'm building a state machine that processes an arbitrary number of parties with the same rules. And what it kind of suggests is that the states were always about the parties and not about the state machines. Like these states of exit, death, um, uh, fleeing, etc. They're about the state that the party got to, but they're not about the state machine state. Exactly, they go together. It was nice the way they went together in the multiple dispatch, but the issue is when I have something with an arbitrary number of parties, I want to be able to run them all. Some of them will, after all the death checks are done, whether there's one or multiple parties, we will end up with some of the parties being dead or not. Like just each party independently resolves whether it's dead at the end by running the KO check, right? And then, or at least that's what I'm contemplating. And then, well, what I would like is if that was like, say there were 10 parties and the player party was in them, but 3 of them died and the player party wasn't one of them. Well, the next thing that happens shouldn't have to comprehend what to do with 10 final states. It should now be like, well, we cared about the player party for this next piece, right? So maybe what has to happen is that each of these interrupts is written in such a way that they don't assume for sure that they know what state the party will be in, just because they imagine themselves being run after the preamble. What actually happens is that after the preamble, anything could have happened. They could have, or at the very least, they could have died, right? And so you have to check if the party is dead and in your condition if you don't want to continue with the interrupt when the party dies. Is that what I want? Is there a concept of a party state that is carrying with the party between calls? What about when we get to the fact of the postamble? Does the postamble want to get automatically skipped because of the fact of the death state, or will they start always running a check to say if the party is dead or not before they make a decision about what to do? The journey. If the player state is dead, then the journey sets its own state to dead. It's passing the death state back up the call stack, right? Getting returned or down, or however you like to think about the direction of functions on a call stack. The earlier functions are receiving the death state and just propagating it up or down, propagating it to the farther depths. I don't know. I can't think of a metaphor that doesn't give a directionality to the stack. How would you write this rule if it was going to be something like this? It might go So you would generate an encounter here, schedule the interrupt. That means running the entire encounter machine to a completion, and you've asked for that here. By default, we always run death checks after as the first interrupt if there is anyone who has 0 hearts. That'll also go first before this. So then, yeah, so this doesn't work. Unless the machine itself knows what to do with the incoming states of each party. Right? I mean, it could be written like this. We're trying to set up a machine. We might be able to say, like, looking at this, there's always 2 parties in an encounter. If either of them is dead, then just go to the exit state now instead of beginning a round. You know what I mean? Like, this could just say, we have a machine for the encounter scheduled here, but the encounter machine never deals with a party that's already dead. That's an exit state. And so this would go straight away to a state that then pops this back off the machine. And then you get to the post sample. That could be the right way to do it. It's annoying that you have to check it here manually. On the other hand, I do want to have the death checks to do something similar. Like, I want the death check here to just go ahead and figure out if anybody is dying, like, right away, right? I want to go... I mean, it's even more than this. I really want to have a conditional check before you even choose to do the machine push. I wonder if I need a slightly different structure here. This tells me how to run the machine, but it doesn't tell me how to do the interrupt, which is also looking for like a conditional. I don't know. I don't know. Let me just close my eyes and think for a moment. Where where do I want to begin? It's like almost there. I just need to pick a place to begin. Well, there is one idea on the table that I think just works. Requires minimal reconstruction. Try wiping out all of the death check stuff. And then instead of going into this loop state death checks, what I'm suggesting happens is the next loop state here would be the postamble. But before you got to do that, you would also have machine call death check okay. It's totally bogus. Where did it come from? Okay. Um, okay. Let's see if death check is actually happening. Like it is. But we didn't get... Do that, you do that. Tell me we never get to this somehow. So what happens next? So random machine init hook. Not empty. Go to the next step. We're in the init now. Pattern is 3.1, but the machine frame was supposed to say 3.3. 0. Oh, there's only one P count. Okay, and it knows that. So we should get a rule. Pre-hook is set and post-hook is set. These look fine. But then we get to bogus before we actually get there. Okay, I see what's happening. Beginning of 2. Okay, let's see. Context P. And P count is 1. Yes. That should be a fine party. But it already looks like bogus. I mean, if this is right, if the debugger here is right, then this is total bogus. So where did that come from? Well, haven't reached this one. There's the call. There's the crash. There's the call, breakpoint, loop state init, array normalize. What's in that machine frame? I want to see what's in the machine frame now. Machine frame says it has P states, a P count of 1, and it's pointing at total bogus. It's pointing at total bogus. Okay. The bogus started before we got here. Where is that call function? Oh, right. Machine call. Right. Okay, I get it. I get what we did. Call array. Call. There is no arg. Hook, and then this is just we're gonna grab the parties and we're gonna do RPG machine call array context machine params count parties. settings. Okay, that looks like an infinite loop. Wish I could double click on it and rename these, or like the right click flow there is just annoying. Okay, so, well, I have a guess. It's probably the KO check that's missing. No, it's right here still. What's going wrong? Oh no. Can't undo that mistake. Still lined up. Lined up. Okay. Sooner or later, we shouldn't be able to keep getting death checks, right? I mean, if we're caught in an infinite loop, though, maybe. I won't really know. What I should probably look at is the step function and try to see if I can get a look at layers we have in the machine frame stack. Yeah, okay, so I see the issue. Since we are now default calling the death check here, we always do that even when we're in the middle of a death check. That's not the way it should be. So what we should do is say if the machine frame, let's see, machine frame, you must know what your machine is, right? Funny that you don't. Machine frame, blah, 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 machine ID equals machine death check. So we don't call death check automatically after running moves if this is a death check. There we go. I'm gonna take this moment do a quick 5-minute break. And then we'll come back and we can fit in another hour or so probably right now. Oh, look at that. That's funny. Yeah, the log is going to deteriorate more and more. What's happening here is, since death resolve is happening within Journey now, right, the post amble of Journey doesn't run. Therefore, the end of the log for Journey doesn't run until here. The end of the log for exit runs here as well, so we get two there, and we get no new line right here before this state. We put the new lines at the ends of states. And the states are now truly stacked. There we go. That'll be better. How is it still two new lines, though? Ah, yes, the stack pop. There we go. That's better. So now we can clearly see the stack pattern. Let's do some other good stuff here. We're calling the death resolve every time now, and that's really going to slow stuff down. Or the death check or whatever. You know what I mean? So, oh, well, okay. One thing at a time. We are just pulling this right out of the loop. Gotta be honest, that just worked. It's pretty cool. Feels really good. The only thing now is I don't think this should be a hard-coded feature of the core loop. I do think this should get coded onto the machine somehow. I don't know how that's gonna happen yet. This is the interrupts thing that I haven't figured out. But the other thing I can do is, let's say from now on, F1 run moves between. That does nothing, that does nothing. That does. Yeah, I don't like this. This feels like this will have to be wrong, the return handler stuff. I feel like I want to change this a little bit because I'm noticing that the core issue here is the framing of the preamble moves postamble. It causes an issue where none of my solutions to problems are exactly fusing the whole thing into like a, it's sort of like building one of these machine loop things. It's like finding a self, repeating lattice shape in the logic somewhere. And when it works right, that extra, you know, something that makes the repetitions fit together as pieces of a larger whole, um, start to stay on the quality that programming it, you don't have a lot of careful restrictions to think about in the vocabulary you use for filling it in. I'm trying to figure out how to describe this correctly. That right now I have a lot of special rules about when it's a good idea to do a go to and when it's a good idea to change character states. Let me show you what I mean. This is a preamble. So if I wanted to here, I could set character states and that wouldn't cause any problems. That would just happen here before all the moves get run. And then it also sets up what moves are going to happen. So it's basically saying this is a preamble, therefore preambles are the sort of thing that run during a init, and they then go into player decisions, so their job is to set up the player decisions. Then there's run moves, which is after player decisions have happened, the moves run, and this can affect player state. So player state is getting affected here in the preamble, and then again here in the decisions. And then after decisions have run, or here in the run moves, and then after moves have run, we run automatic interrupts, death checks. So anything that needs to always be applied, rules that get applied with it, like, automatically. They're always following around and ready to pounce when the rule applies. They take effect. Those rules now take effect and can respond to changes in the state that occurred during the preamble and the running of all the moves, right? Now, there was some tension thinking this through about, like, should a death check actually run separately before, during an encounter, should there be a death check when someone has poison and before they even choose moves at the beginning of the round they take a damage, if that's, a thing. And I decided to just say all death checks would happen all at once in one spot in the encounter loop. And I arbitrarily placed that. Well, not arbitrarily. I carefully decided the best place to put that was here, because this is after all of the character state changes have happened in an encounter, right? But then I went and made that death rule, and its idea is that during the postamble, it's discarding dead characters. So it actually does change character state in a meaningful way here, essentially. And while that's fine, this is just completing a piece of logic. It makes sense within the case of the death check. It now means that there's not as much of a clear rule saying that the postamble is just about figuring out where to dispatch to in terms of the next rule, right? This postamble here is definitely not doing that. It's saying we're going to complete some state changes that were kicked off by the application of this rule to begin with. Which still doesn't totally violate the rule yet. But then I get thinking even more, and I'm thinking about how maybe what I would have is there'd be this idea of hooking time. So if you go on a journey and you get to the end of, you finish your encounter, and then you've crossed some space and you've spent some time. Well, when that time gets spent, if the way poison works is that each time time increments you take one damage, well, then where are your death checks now, right? This here wouldn't, if time increments like this, then um it could just be that the problem here is that I've put this effect in the wrong spot. Maybe this should be happening in the preamble before the encounter occurs. Um, that would make sense in a couple ways. It would mean that you don't get surprised by an effect going off here. Well, I guess what I'm saying is it feels weird to me that there's this. In this case, it's not even in a postamble, it's in the return hook or return handler, which is even more odd. Because here's the return handler, right? And the next thing it does is end this iteration, right? It's just going to go to the next thing in this. It's going to go to a new preamble. And maybe the return handler is just wrong, and what should be happening here is a change of state. So this should just be whenever you return, you go straight into the preamble of a different rule. But this particular rule wouldn't involve you taking any turns. It would just involve running some effects. And effects happen in the preambles. And the reason effects happen in the preambles is because they can still trigger things like death checks, right? So is that the rhythm? There's no more return handler, and instead you always set up a preamble, but we're going to just start allowing preambles to be closed on their own so that they say, hey, do all this stuff, and when you're done, there's actually no postamble to this rule. There's no moves to run. There's no decisions to make. So I will just encode the go-to as well for this state machine. But in the meantime, there's also possibly interrupts queuing up for effects like if time caused poison to cause damage and killed somebody and there's a death check happening, then you still use that, you know? I think that could be a worthwhile experiment to do next. To try to flesh this out a little more cleanly. So this would mean that return handlers were written the wrong way. Instead of saying that to set a return handler is to set a hook, it would actually be to set a state ID. This would be RPG rule pre RPG state raw journey travel end or something like that. Journey travel end. Because the other idea I had was to try to find just a totally unframed rule description where each state is just the same sort of thing, or maybe there are some type and not a Lego brick, but there are states that connect to each other somehow, and preambles and postambles wouldn't be necessary, right? They would just be code followed by flow to another state. And the way I was picturing this could work you're in a state and you set up a player move, then the player move is going to run, and then another state is going to resolve the player move into a next step, like into whatever, a state change, a change of another go to. I think I'm on the right track though. There's something about this that feels like it just works a little better with the preamble postamble still, and I think it could be just a verbiage thing. Like it might be that this is common enough that the occasionally having an extra one that's like journey travel, and having a pre and no post, because this is really sort of a three-step thing that might feel funny, but what it would cost to make this generic so that I don't have to do that way is it would mean that when this says here's the decisions I want the player to make, it would also always have to say here's the state I want to go to. Now, saying which state you want to go to wouldn't actually be that bad. If you knew that was always going to be just a single, like it wasn't going to be these arrays anymore, right? These go to array, go to the multiple dispatch adds an extra layer of annoyance there, but this could just start looking like RPG rule script. This won't be necessary anymore because we'll probably start doing something more like journey travel, or journey travel, something like that. But journey travel. We set what decisions we want the player to make, and we set that the next machine state is journey travel encounter. Right? You see where I'm going with this yet? And so then you make some decisions, stuff happens during that, and after that, after whatever all of this does, an encounter will occur, which is somehow you still have to call the encounter with multiple parties, so that's fine. But you call the encounter with you run the encounter, and right, and so the point is you'd always end one of these states with a next state unless you intend for it to loop on itself. And then you would also be able to say a call is basically saying what's happening, like setting something up the stack. So this sets its next state here at the same time that it's doing this call. Maybe whenever you make a call, you are also setting your next state with that. Right? So you're saying here's where we're going to go to next when we return. Here's the call. And then this becomes this. Right? This is next state. This is the hour increment. And so if each of these is just like a preamble, they just run ahead of time. Some of them call for player decisions and some of them don't. Some of them after the rule runs and the decisions run, then interrupts can run. And interrupts can cause calls to happen. But then these can also cause calls to happen. When one of these causes a call to happen, what the way this is interpreted, I think, is this does whatever it wants, including setting up some change of state. It's really saying put this in as a interrupt next, right? So if there were decisions here, you would still run decisions. You set up the next state, so you're gonna go to that one next on this frame, and then you say, okay, after running death checks with all the normal interrupts, there's one more interrupt that has been set up, which is this one, which is going to go, and then when that's done, it's going to return here. So the thing is I think this is all going to work. It's just going to mean I have to get off of multiple dispatch for the encounter system, which is going to be, that's the one reason why the multiple dispatch is so nice, is the encounter system, it really was made for that, and it's a little overcomplicated for that case too. But I think it'll just be better because honestly, most of the game code isn't going to be in the encounter system. The encounter system will be like one big gigantic internal beating heart that will, like, lots of things will depend upon it and flow through it, and it'll matter tremendously. But in terms of the maintenance burden, I think there's going to be a lot more of these things. These sort of framework structuring things that put encounters together in different balances. State machines which employ encounters in different textures. Streamer99, in this case, so the encounter system, whenever I'm creating one of these rule scripts in the encounter system, I have two different states, one for each of the parties in the encounter. And so the entire rule system, it's basically a state machine system, although I call it rules because the state also encodes some rules about what to do in the game at that state. And the states themselves are these tokens here. So this tells us what state the rule is for. This is the rule script that goes on that state. When I first set it up, I was really thinking about the encounter system where there's a pair of parties, fighting or otherwise engaging, maybe having a chase scene. It's the other possibility right now. So when it's this, two parties squaring off in some way situation, that goes through the encounter system, which uses a double dispatch, right? I have a state for each party. And so my rule isn't just saying the rule for this state, it's a rule for a pair of states. And then anytime I want to figure out what state I'm in, I look at the pair of states on the parties I actually have, and then I look at all the rules that might match that, and I also sort the state. So what happens here is, like, you'll see this as flee fight. I don't need another one that's also fight flee to mirror it. The mirroring is automatic. The mirroring is automatic because of the way that I sort them before I compare them. So that's cool, but it actually led to a lot more complexity than I would like, and it's feeling like the rest of the systems will become easier if I wasn't on it anymore. So I'm going to move in that direction probably next. Which means I was right. We are actually finally going to tear up the state arrays today. State arrays aren't going to make it anymore. I think instead what needs to happen is we just go to a single, a single dispatch state machine system, that's gonna have a couple of great benefits. But the only downside it's gonna have is that we're now gonna have to. Okay. I want to actually make sure I'm paying attention and get the spot where it's ready to work properly. I think this is it. Okay. But I need to think through how I'm gonna recreate this possibility here, right? So I think what needs to happen is that occasionally I need to be able to run a pair of these states through a map down to a combination state. Right. So then what'll happen is, in a spot like here, each party gets to make a decision: would they fight or flee? And then, based on their decisions, we dispatch to the state. Here, what we would do is we'd say we grabbed a decision from each of these parties, and we're going to have to do something like something like this, right? Where we can map a pair of party states back to a single state, and then RPG machine next state can just say context next state, right? That's kind of what I'm thinking has to change. And that's pretty much just right here, and then all of the code linking the rules together will change with it, and then we'll somehow need to specify that map. So first things first, to specify the map, I think we need a new C scripting symbol set. Actually, let's just go. So these are the state symbols. Yeah, I think, man, I think today I'm just going to tear it all up. It's going to be one of those days where I just dig in. These are going to be machine states. Machine state. Party state IDs. These will just be called states. State symbols. Right. And then everywhere where I talk about state def, um, I'll do that. Yeah, these can just stay. I think that's still the easiest way to do it. Ooh, paging Turner, how do you do that? What is your profiler setup where you're what do you, I've never done a profiler setup where I have enum entries. Is it like, are you using the enum in the sense of you don't want a full C string to label the block, you want something lightweight? That makes sense. Yeah, I mean that's a good place. Just when you want to be able to generate enums fast, like non-locally, that's a definitely one of the use cases that would be good. Um, Makes me think I should make sure that I can define these in local scopes and get the correct behavior. That would be cool, and it might be possible, but I'm not sure. It might not be. I can't remember how that works. Of course, that's also strange because I mean, if your profiler is built into your program, that's perfect because then you can attach. You can still have string data for the display. You just don't have to use it in the um, timed block buffer, which would be huge. Be able to avoid that. Yeah, right now I'm just okay. This is all just sort of playing with it being totally bogus. Like I said, I'm tearing it up pretty bad right now. So party states go there. Now, let's see. Encounter fight. Encounter flee. But yeah, we're gonna go. I'm gonna say machine go to. All of this is overcomplicated and not happening anymore. From now on, it's just RPG machine next state, RPG context, U32 state ID. While I'm here doing this, let's go ahead and say we need to visit the rule and rediscuss. Where is this? Rules pre. Yeah, rule proto raw states. No. No, all we need is the raw state. There's one raw state. For now, we'll keep pre and post. That'll be a separate step. That means we don't need arrays here. It means we don't need variadic arguments either, so instead it's just an S. rule symbols, function name. Yeah, we don't need all this anymore. We're gonna change this to be like this. And this. That's all we need. N and P. That's gonna go and rule script post. You're out. You're out. What we do need is RPG state raw on the N. That's the state. And this is the function, and this is the function. Okay. Okay, so the machine sets up, and it should first machine next state, RPG state encounter round. RPG state def encounter round. And then this is rule pre for encounter round. This is rule post for encounter round, and that's just how that works. This is for encounter fight. And here's where I want to be able to go, okay, I want an RPG encounter state map. I want to map the encounter fight to the encounter fight. I know that's confusing. It's because I have encounter fight state in the party states and an encounter fight state here. They're separate symbols. They happen to have the same name. So this is mapping a pair of encounter fights to the encounter fight state. How are we looking so far? Yeah. So yes, this simplifies this down. Now we can just do this right, which like this, and then the post is this. Rest. Okay, so this is the encounter fight post. This should be machine next state is encounter round. Go back and do another round of the encounter. Now, if we do a state map, flea fight goes to encounter flea fight. So now we're just going to say, you know what, screw it. Get me the fleeing in party. That's probably easier than all this permutation stuff I was doing before. We'll actually come back and implement this later. But fleeing party is where, this is where we actually do dispatch to one party. I was saying earlier this doesn't happen, but I was wrong. This is the one spot where I do, in fact, pick and choose which parties get moves. So that's the thing I do want. Okay, this is encounter flea fight. And this is go to. So that's next state. Encounter flee chase. Counter flee chase goes here. So it does feel like this makes the encounter just slightly more tedious to set up. But honestly, I don't even need much out of this dispatch. This could literally just be go quick hack right here for a while. Right, like this could just look like flea fight goes to encounter flea fight. and Fleet. These are the only ones we need because these are the only decisions we actually support up here anyways. The other ones aren't even in the dispatch problem. And so this could just be a matter of saying we want to look at the states that were chosen by each party here and have a little dispatch here. Now, I think that this won't always be the way I want to do it. Because if this gets big enough, it'd be nice to actually have some kind of acceleration the ability to pre-build the acceleration, which means I wouldn't want it to just be this local little array thing. But for now, why not? Array count party to machine map. I is gonna plus by 3s in this. We're also gonna if 0 this part out because the other thing we have to do is get the oh, I guess we don't have to. Okay, I'm gonna have to pick it up from here. I'm a little bit out of time right now, but some things are going wrong. So all of this still assumes that the order tells us something about the parties, like right here, speed 0 and speed 1. And so actually the asymmetry just isn't being programmed properly here anymore. This is a part of the advantage to having the permutation system set up was that it kind of made making the rule symmetric automatic, and I might just need to give that up and make them symmetric a little bit more by hand. I'm not sure. But we're getting there. I do think this is a direction I want to finish, so I'm going to come back after a couple hours and I'll spend the rest of the day getting this back to working with this new concept of a split between the machine states and the party states and see if that makes things fit together a little nicer with everything else I was looking at regarding the journeys and the interrupts and the possibility of getting off of the preamble post-amble structure to just having rule setup, decisions, calls, and next states. So I think I'm going to call it here for now, and I will see you all in 1 or 2 hours. Later.